Welcome to Klein's Geometry. Today we're going to talk about Lesson 4-8, Isosceles and Equilateral Triangle. Two different kinds of triangles. We've already discussed them. Let's look into them in a little more depth today. First thing you want to know are the parts of an isosceles triangle. As you look at it, you'll see two legs. Those are the sides that are the same length. And right in between them is a vertex angle. Okay, that's the angle the two legs make. The side that is not the same as the other two would be your base of the triangle, and connected to each side of the base are the base angles. Notice the base angles are opposite the legs. Now this triangle just happens to be sitting on its base. It doesn't have to be. If I told you that these two sides were congruent on this isosceles triangle, that would make these the legs, and this side right here that's not the same length as the other two would be the base. That would put our vertex angle, since it's always between the legs, leg, vertex angle right there. And base angles would be across from the legs, so there's the base angle right here, and here's the other base angle right here. Now, I know I can find my base angles real nicely. If I cover up this leg, I see the angle that corresponds with it. That's the base angle that goes with that leg. If I cover up this leg, I see the angle that goes along with it, so I know that that's the base angle. Now, if I cover up the base, I see the vertex angle. So, might be easy to find your way around the triangle by just covering up parts to see. Now, what do we know about isosceles triangles? Two things. Here's two theorems we want to look at. One, isosceles triangle theorem. If two sides of a triangle are congruent, the angles opposite to the sides are congruent, those base angles. The converse of that is also true, called, surprisingly, the converse of the isosceles triangle theorem. If two angles of a triangle are congruent, the sides opposite the angles are congruent. So the thing that I want you to take away from this is if you've got two congruent sides in a triangle, guess what? You have two congruent angles in that triangle also. Likewise, if you have two congruent angles, that means you're going to have two congruent sides. So you want to keep that straight. Makes sense if you are thinking about an angle opening up. Think about my hand forming an angle. Notice that the distance, as my fingertips move apart, the angle between my two fingers is getting bigger, and the distance between my fingertips, right there, that gets bigger as well. So the bigger the angle, the bigger the distance between my fingertips. The smaller the angle, the smaller the distance between my fingertips. There's got to be that relation between the angle measure and the side length. Let's look at how we'll use this. You see an example in your book, example 1. It talks about a star and it's rotating around the sun, and they measured from this satellite. They've got our sun here, and they measured that this measure was 90.4, this was 89.6. They said, explain why L to M, this length here, is congruent to L to K. Well, when you first look, it's absolutely not obvious, but then you look a little further and you think, what measures can I figure out? Well, we know that this angle and this angle form a linear pair. So if I always find my angles. That helps me see what's going on. So if I thought about this as 180 degrees, I know that 180 minus 90.4 should give me this angle here. So I'm going to take that 80, borrow 1 from it, so 79.10. 10 minus 4 is 6, 9, 17 minus 9 is 8. So I just found out this is 89.6. Well, that tells me all I need to know, because now, since the angles are the same, I know the sides are also the same. So I would say LM is congruent to LK by the converse of the isosceles triangle theorem. Which says if the angles are alike, the sides must be. Okay? Now, so that's one way we might use it. Now, the other thing we might be asked to do is simply find the measure of an angle. Well, we know there's only going to be 3 angles here. So let's look at this example first. Okay? We're going to look here, and the first thing I'm going to do is I'm going to look at this and I'm going to say, okay, label this. I know this is the vertex angle. So this is a base angle. It's across from here. This is across from here. So these two are the same. So that's x also. So then I can use this idea that I've always known, well, not always, but for a couple lessons, that the sum of these 3 angles is 180. So x plus 38 gives me 180. Well, if I simplify this, I've got 2x plus 38 is 180. And when I take 38 away from both sides, I get 2x equals, let's see, I'm going to have to borrow one. 10 minus 8 is 2, 7 minus 3 is 4. 2x is 142, and then if I divide by 2, 2 goes into 14 7 times, and then 2 goes into 2 once. So I've got x equals 71 here. Now that's the measure of this angle, and it's also the measure of this angle. A little quick check. Let's see, what's 71 plus 71 plus 38? Better be 180. 8, 9, 10. Carry the 1, 10, 17, 18. So I know I did it right. So that's one way you can do it. You know, if this is x, that's got to, whatever this is the same. And these 3 together have to be 180. Now, you might get something that looks like this. And if I looked at this, I go, whoa, I don't have any expression here. But let's see, this is across from that angle that I know is these 2 sides are congruent, and so these 2 angles must be congruent also. So then I could say x plus 30 equals 2x by the isosceles, converse of the isosceles base angle theorem. So this one is congruent to this one. And then if I take x away from both sides, I've got 30 degrees equals x. Well, don't think that tells me my angle, though. So that means the measure of angle r equals, and I have to come back up here, get my expression, x plus 30. So I'll write 30 plus 30, and I'll get 60 degrees. I'm going to check the measure of angle s. That's going to be 2x, so that's 2 times 30, and that's also 60 degrees. Now, to find the measure of angle t, all I have to do is say 180 minus these other 2 angles. 2 times 60. And that's going to be 180 minus 120. Well, it turns out, in this case, t is also 60 degrees. So it's not only isosceles, which has at least 2 congruent sides, it's actually equilateral, because it's got 3 congruent angles, which means 3 congruent sides. And that leads into the final definition, which is, if you have an equilateral triangle, it is a triangle with 3 congruent sides, and we talked about this a little earlier. If it's an equilateral triangle with equal sides, it's also an equiangular triangle with equal angles. So this means equal sides, equilateral, and this means equal angles, equiangular, okay? Now, we also know if it's got equal angles, they're each 60 degrees. So that's going to come in handy. Now, when we use properties of this, we just use these facts. You might get a picture that looks like this. You've got triangle ABC. Well, I see tick marks on all the sides, so I know they're the same. But I'm asked to find x, and I have an expression for an angle. But I put on my thinking cap, and I say, okay, equal sides means equal angles. So I know all these angles are the same, and they're each 60 degrees, so I can say 3x plus 15 equals 60. Take away my 15 from both sides. 3x equals 45, divide by 3, and I know x equals 15. And that's about all you'd have to find. You wouldn't have to plug it back in to find the angle, because we know the angle is 60 degrees. Okay? The other thing you might get would be a triangle that looks like this. Here, you're given all the equal angles. And you're asked to find side lengths. But you think, equal angles, equal sides. They go together. Like peanut butter and jelly. They go together. So, equal sides, equal angles. If I know if the angles are equal, so are the sides, and I can say 4t minus 8 equals 2t plus 1. I can solve for t, plug it in, find my sides. I'll start by getting my variables on the same side, opposite signs, and get 2t minus 8 equals 1. That's a big 0. Then I'll get my numbers on the other side. I'll add 8. That's a better idea than 9. And get 2t equals 9. There's another 0. I'll divide by 2, and I won't panic because it doesn't go in evenly. 9/2 is a very good number. 9/2. You might have written 4.5. Either one's good. Now to find my sides, well, KL is going to be 4 times t minus 8. For t, I am going to put in 9/2. And I like to do it this way, because then it's easy. I just say 2 goes into 4 twice. Fraction brought up the division sign. So I have 2 times 9 is 18 minus 8, and I get 10 for the length of KL. I can do the same thing for JL. I'll say 2 times, I need to put in t, and I'm going to put in 9/2 again. Well, then it's even better, because 2 goes into 2 once, and I just have 9 plus 1 is 10. So I know all three. I can say that JK plus or equals KL equals JL equals 10 units. Every single one. They're all the same. Every one equals 10. Because all three sides are the same. Even though I had no expression here, I know that all the sides are the same because all the angles are. So, remember, if you've got an isosceles triangle, the base angles are equal also. If you've got an equilateral triangle, the sides are equal, and they're all 60. And if you can remember that, and if you know the sides are equal, you know the angles are equal. If you know the angles are equal, you know the sides are equal. You are golden. Take care, and until next time, enjoy. Math is always fun.